All right, welcome back. We are going to be working on Unit 1, Lesson 11, and Lesson 12. Unit 1, Lesson 11, Identify and Solve Proportion Situations. This is on page 29. So again, in your black notebook, draw a line, and if you would please write Unit 1, Lesson 11, Identify and Solve Proportion Situations, page 29, and today's date, whatever that may be, for when you are watching a video. So let's look at this. It says making assumptions. Write the assumptions that must be stated to make the problem a proportion problem. Make and label a factor puzzle for the problem. Box the unknown and solve the puzzle and the problem. So here we go. Making assumptions number 1. Two bands march in rows onto the football field. When band A has 15 people on the field, band B has 6. When band B has 14 people on the field, how many people will band A have on the field? So over on the left here we have our factor puzzle. Over on the right here we want to write down what is our assumption. What must be stated to make the problem a proportion problem. So just like we've done before, we have band A and band B. So I'm just going to put A and B. And we have, when band A has 15 people on the field, band B has 6. So 15 for A and 6 for band B. And then it says when band B has 14 people on the field, how many people will band A have? So when band B has 14, how many will band A have? So now you have your factor puzzle. So if you haven't done that yet, copy that into your notebook for number 1. And we need to solve for the box there. And then what assumptions do we need to make? Well, let's just solve it first, and then we'll kind of look at the assumptions afterwards. 15 and 3, what factor goes into 15? That also goes into 6, and hopefully you recognize that 3 will go into both. 3 goes into 15 5 times, and 3 goes into 6 2 times. Oh, I'm sorry, 3 times? Oh, no, that's right. 3 is over there. Excuse me. I was right. And then bring the 5 down. Bring the 2 down. 14 divided by 2 is 7. Bring the 7 over. 7 times 5 is 35. So you just solved. So problem solution would be 35 people. How many people will band A have on the field? It would be 35. Now, what are the assumptions? That's the tricky part. So, what are the assumptions? All right, over on the right, you can see what the answer key has. It says each band member starts at the same time. Each band continues to add rows of people onto the field at the same time. So you're making the assumption that they start at the same time, that band A comes in at the same time band B does, and you're making the assumption that each band continues to add rows of people onto the field at the same rate of that 5 to 2. That's what you have to assume for this factor puzzle. Let's try one more. Problem number 3 says Joshua has 32 angelfish for every 12 snails he has. How many snails will he have when he has 72 angelfish? So let's start with the factor puzzle. 32 angelfish for every 12 snails. So on the line above, you have your angelfish, and you have snails. "32 to 12. 32 to 12. Okay? And then it says, how many snails will you have when he has 72 angelfish? So now he has 72 angelfish. How many snails? So the first thing you have to look is, what are the factors of 32? What are the factors of 12? What will go into 32, and that will also go into 12. So 32, 8 times 4 is 32, and 4 times 3 is 12, so let's try with 4. 4 goes into 32 8 times. Bring the 4 over. 4 goes into 12 3 times. Bring the 3 down. Bring the 8 down. 72 divided by 8 would be 9. Bring the 9 over. 9 times 3 is 27. So if we did our factor puzzle correctly, we should have 27 snails. And then the hard part. What must we assume? What assumptions? So let's take a look at that. Just going to pull down so number 2 is visible. So we do have, so if we look at it, our factor puzzle is correct. 27 snails, and then the assumption would be, and I do want you to write this up just like you did for number 1, Joshua needs to have started with no angelfish and no snails. Okay? Then he adds batches of angelfish and snails with the same basic ratio. Again, he has to add 8 to 3. So every 8 angelfish, he has to add 3 snails. So if he would change that up, then this would not be correct. So that's what you need to write down. We will skip number 3 because I think you have, hopefully you have the idea by now. If we were to do number 3 and you don't have to copy this down, the write-up would be 5 to 2, and it says Ann and Jim plant for the same amount of time and plant at their own constant rate. So again, it's that constant rate deal that they're looking for here. All right, let's move on to page 30. Still working on identifying and solving proportion situations. And then over on the right here, it says for each problem, Ann and Jim plant rose bushes for the same amount of time as they're at their own constant rate. So it's telling you that they're planting them at the same time and the same amount, at the same rate, at their rate. Tell how these factor puzzles relate to each other and to the proportion problem. So, looking at factor puzzle 1, Ann 5, Jim 2. Okay? 35 to 14 or 15 to 6. And then it says proportion problem number 1. Ann planted 35 rose bushes while Jim planted 14, 35, 14. When Ann had planted 15 rose bushes, how many had Jim planted? And that's what you have to solve. So it's boxed and it's 6. Okay? Now let's look at factor puzzle number 2. Jim planted 14 rose bushes. There they are. And while Ann planted 35. Okay? How many rose bushes had Jim planted when Ann had planted 15? So here you have 15, and here you have boxed 6, because you solved for 6. Now, if you look at Ann and Jim, and now it's Jim and Ann. Okay? Now let's look at the third one. Number 3. When Ann plants 15 rose bushes, how many does Jim plant? Okay, so if Ann plants 15, Jim plants not sure, so we box it. Ann plants 35, Jim plants 14. So the boxed up here is now on top. But it's still the same information, it's just in a different order. So that's what they want you to look at. It's still representing these proportions with factor puzzles, but just showing you different ways to set up your factor puzzle. So with that all being said and done, then number 4 says, write the tricky reverse question for each factor puzzle. All right, so what did they do in factor puzzle 1 that was tricky? So they want you to write what they call the reverse question. So if you go back to 1 here, Ann planted 35 rose bushes while Jim planted 14. When Ann had planted 15 rose bushes, how many had Jim planted? That's what they're looking at here, looking at this factor puzzle. So let's go to number 4, and I'm just going to put the shade on there, and just so we focus on factor puzzle 1. So write the tricky reverse question for each factor puzzle. Factor puzzle 1. How many rose bushes had Jim planted while Ann had planted 15? That's what they want you to write. So let's look at factor puzzle 2. I think I got to actually go, nope, hang on, sorry about that. Let's go back. All right, so Jim planted 14 rose bushes while Ann planted 35. How many rose bushes had Jim planted when Ann had planted 15? Again, it's the same information, it's just reversing it. So let's look at what they have for write up puzzle number 2. So number 4, factor puzzle 1, looks like that. And then factor puzzle 2, when Ann planted 15 rose bushes, how many had Jim planted? Okay. And then let's look at factor puzzle 3, and that's this one right here. When Ann plants 15 rose bushes, how many does Jim plant? Ann plants 35 rose bushes while Jim plants 14. Okay, just another way of representing the same data. So in your black notebook for factor puzzle number 3, look at what they have and write this down. How many rose bushes does Jim plant when Ann plants 15? So how many rose bushes had Jim planted while Ann had planted 15, or how many rose bushes Jim planted when Ann plants 15? It's just, basically kind of just a play on words there. It's the same data just being represented in 3 different ways. So factor puzzle 1 for 4, 2, and 3. Jot those down and just don't get too hung up on it, but just kind of realize that really it's the same way, it's the same information just represented different ways. All right, so your homework or your schoolwork will look like this, and basically it's wanting you to tell why the situation is a proportion or write the assumption that must be stated to make the problem a proportion problem. So now again, they want you to write that assumption. What are the things that you have to assume? And then also completing the factor puzzle for it too. And let's just take a look at number 1 here. All right, to make a pale blue paint, Eric mixes 6 cans of blue and 10 cans of white. She has 35 cans of white paint. How many cans of blue does she need to get the same pale blue? So down below, you put in the information, 6 cans of blue, 10 cans of white, 35 cans of white, how many cans of blue? And then you look at the 6 and the 10, you find that they have a factor in common, 2. 2 times 3 is 6, 2 times 5 is 10. Down below, bring the 5 down, 7 times 5 is 35, so 7 times 3 must be 21. So the answer is 21 cans. And now, an assumption. You must assume that the same color will have the same ratio. Same color will have the same ratio. And that's how you do the rest on that. The remembering page, more factor puzzles, and then is the table a ratio table? Write yes or no. If yes, write the basic ratio at the top of the table. So more of what we've done already. And then down below, represent the situation with an equation, solve. Use parentheses if needed. So you're solving the problem and then writing that equation. If you need parentheses, use them. All right, draw a line in your notebook and then write lesson 12. Solve numeric proportion problems, page 31. Numeric proportions and factor puzzles. So now, basically, it's the same as what we've been doing. It wants you to represent, oops, sorry about that. Let's try this again. Represent A to 32, which is equivalent to 15 to 40 in a factor puzzle. So if I do my factor puzzle, oops, I think that'll work. Let's make it smaller. Can I make it smaller? Thought I could. Well, I can use this. All right, so we have A to 32, 15 to 40. Okay, and then just like you've done before, you have to add these lines on the outside and top and bottom. 15 and 40, look to see what they have in common. 5 goes into 15, 5 goes into 40. Does anything higher than 5? I don't believe so. So 5 times 3 is 15. 5 times 8, bring the 8 up, bring the 3 up, and so on. Okay? 9 divided by 3 is 3. Oh, I'm sorry, that's not it, that's an A. Sorry about that, let's try this again. 32 divided by 8 is 4. Bring the 4 over. So 4 times 3 is 12. So A would equal 12. Let's say it's hard to read, so let's actually just bring up the page with it. Just going to put my screen on, so we're only focused on, well, it shows 2 and 3, but that's okay. So there's your factor puzzle, A to 32, 15 to 40. Go ahead and look at and write down number 1. And then 16 to 36, write down number 2. 16 to 36 is the same as T to 63. So 16 to 36, T to 63, finding the largest factor that they have in common, and then solving for T. So copy down number 2 as well. Don't worry about number 3. So 1636, what factor will go into 16, what factor will go into 36 is what you were trying to figure out. What other factors of 16? Well, 1 goes into 16, 2 goes into 16, and so on. And then what factors of 36? 1 goes into 36, and so on. On page 31, let's take a look at this. It says patterns within proportions and factor puzzles. These proportions have been set up for you. What patterns do you notice? So they want you to look at the pattern now. So all really they're doing is just really breaking it down. 2 times 5, 2 times 5, and then the dot represents multiplication. 2 times 12, okay? And so on. Then you have 13 times 5, and 13 times 12. Now, they're just asking you to look. Now, look at this one here. 2 times 5, 2 times 67. 39 times 5, 39 times 67. Or A times C, B times C, A times D, B times D. You don't have to copy any of this down. Just take a good look at it, and then let's move on. All right. Let's look at page 32. So on this page, they want you to look for proportions and non-proportion problems. They want you to look for the difference, to differentiate the proportion from the non-proportion. So what it wants you to do is circle the number of each problem that is a proportion problem and then solve it with a factor puzzle. Circle the basic ratio in each factor puzzle. If a problem is not a proportion problem, tell why. Okay? So let's look at number 10 first. Number 10 reads, Peachy Paint Company used 20 cans of blue and 15 cans of yellow paint to make grasshopper green paint. They have 8 more cans of blue paint. How many cans of yellow paint do they need to make more grasshopper green paint? Okay? So they want you to set up a factor puzzle for number 10. All right, so if you look at the right, the factor puzzle is in place. 20 blue to 15 yellow. 8 more cans of blue. And then your box, which would be your unknown, which I've solved here, is 6, because 5 times 4 is 20. 5 is the common factor. And 5 times 3 is 15. Bring the 4 down, bring the 3 down. Then you have 8 divided by 4 is 2. And 6 divided by 2 is 3, or excuse me, 2 times 3 is 6. So, how many cans of yellow paint do you need to make more grasshopper paint? If you had 8 more cans, you would need 8 more blue cans, you would need 6 more yellow. So the first part would be 6 of yellow. And now, is it a proportion? That was the next question. Circle the number of each problem that is a proportion. And it is a proportion. For every 20 cans of blue, you need 15 cans of yellow. Same as for so 8 cans of blue. Just because it's a smaller amount, you still need that same ratio that you were initially given of 20 to 15. So that's where you'd end up with the 6. So yes, this would be a proportion, and you should circle number 10. So let's look at a number 11 now, because see the difference between which one is a proportion, which one is not. 11 says Mr. Talley's art class uses 2 bags of markers each week. Mr. Petro's art class uses 3 bags of marker 1 week and then 2 bags the next week. So right there, right off the bat, it says that because he uses, oops, sorry about that, I wanted to highlight. 3 bags 1 week, 2 bags the next week, and continues this pattern. If Mr. Talley used 14 bags of markers, how many did Mr. Petro use? Because he's changing from 1 week to the next, this is not a proportion. And that's what you'd be looking for when you're when it's asking you to solve, if it's to circle if it's a proportion, and then solve it. So there's no constant rate. All right. So here it shows that 10 was circled, 11 is not. If we continued on, and if you want to look at it, 12 would be a constant rate, 13 would not. All right, homework, you would be setting up factor puzzles for each proportion, and for the assignment at school, and then the remembering would be the same, more factor puzzles, and then down below here it talks about circle each ratio table below, write the number to show the 2 multiplication columns that are in each ratio table. Let's take a look at what one of those would look like. So, circle each ratio table below. Look at number 4, 5 to 7, 10 to 14, 15 to 28. Okay, 5 to 7 looks great, 10 to 14 looks great, but now 15 to 28. So if you're taking 5 and it's going 5, 10, 15, that's perfect. But if you're going 7, 14, the next number would have to be 21, not 28. So that's why 4 is not circled. Number 5, on the other hand, you have 3 to 7, 6 to 14, 9 to 21. 3 plus 3 is 6. 6 plus 3 is 9. 7 plus 7 is 14. 14 plus 7 is 21. So your unit rate would be 3 to 7, and you would circle it because it is a ratio table. So now look at 6 and look at 7, as well as when you get this assignment complete, circle number 5. Okay, and then look at number 8 here. It says represent the situation with the equation, solve, use parentheses if needed. And then it says equations may vary. Some students may use the X sign instead of the dot that represents multiplication. I don't know, that's Marna's display has 3 rows of stamps with 9 stamps in each row. Ned's display has 1 fewer row, but 2 more stamps in each row. How many stamps are in Ned's display? So let's take a look of how they're going to write this up. So you got Marna's display has 3 rows of stamps with 9 stamps in each row. Okay. Ned's display has 1 fewer row, so it only has 1 fewer. So instead of 3 rows, 1 fewer row, but 2 more stamps in each row. So in those 2 rows that Ned has, he has 2 more stamps in each of those rows. So what is that going to look like as an equation, and what would be the answer? So in Marna's display has 3 rows of stamps with 9 stamps in each row. Ned's display has 1 fewer row, so that's where you get the 3 minus 1 in parentheses. And in times, Marna has 9, Ned would have 2 more, so then it's the 9 plus 11. So that's what your equation would look like. Then you would solve it. 3 minus 1 is 2. 9 plus 11 is 20, so you have 2 times 20, which would be 40 stamps. So that's how you'll do the next one, and I think that's it, just number 9. All right, and we will work on this in class as well. That concludes our 2 lessons, lesson 11 and 12.